So this class is being recorded. If you do not agree, you can drop off from the call, and this will be shared with one of the student who is not attending the class. Cool.
I
So
agree, sir.
cool. Great. So yesterday we discussed around system design fundamental, right? Design fundamentals. Any questions you have before we move forward?
No, sir.
Yeah. Cool. So let's start with the next step, which is cap theorem, right? And cap theorem is the fundamental of almost all the design, and that is where you trade off a lot, right? When you do a system design, it's all about story of a trade-offs, right? So there is no perfect world. Yesterday we realized that, hey, when you do the sharding, the shards become the critical. If the shard goes down, the data movement happen, right? All those things, right? So it's all about trading. So you trade off one thing over the other, right? And what are those things? When you say, like, what are the currency of trade-offs here, right? And that is what the cap theorem defines. So cap theorem is a very important theorem in distributed systems, right? Distributed systems. And what it says is, it says, like, first of all, let's define what is C. C is consistency, right? What is A? A is availability, and P is your partitioning of network, right? So what it does, the cap theorem says is, like, if you are designing a distributed system, right, you can have only two of this. You cannot have all three of this. That's not possible to design a system which has CAP, all of three together. So you always trade off one over the other. So for example, if you want to trade off on consistency, then sorry, if you want to improve consistency, then your availability may go down. If you are improving availability, then your consistency may go down. If you're doing availability and network partitioning, then your consistency goes down. So you can get only two of them, right? Usually we go for AP or CP systems. So either we'll go available and partitioning tolerant system, or we will go for consistent and partitioning tolerant system. We do not go for CA systems because that's consistency and availability. That creates problem because partitioning is important. Like, what if the network got partitioned? So let me tell you a story and explain this whole concept of consistency, right? Mm, or cap theorem. So let's say I build a service as a person, like real world. I build a service. This service does only two jobs, right? It So I am sitting here as a person, right? And I have a telephone, right? So my user calls me and tells me, like, hey, note down my birth date. Date of birth is this. My wife's date of birth is this, and then this birthday or this, and then my child birthday is this. So it updates date of birth of everyone. Yeah. And the second interaction it has on this is, one fine day in the morning of January, it calls me like, hey, tell me if somebody's birthday is coming up in this month, right? And then I look at the data and then return it back, right? That's the only basic service I have in my and I am sitting with a phone. Somebody calls me on phone, and I just look at the data which I have, maybe in diary or something, right? And I just tell them, like, hey, this is your birthdays, right? What is the problem now? Right, this service is going good, what happens now? One fine day I fall sick. Yeah. Now there is nobody to answer the call for date of birth, and there is nobody to actually take the call for the updating the date of birth. What went for a toss here?
Availability.
Availability, right? So my availability is now a problem, because if I have, like, imagine myself as one server, right? And one server goes down, and now my service is down. Like nobody can update or nobody can get date of birth. It's not a great idea, right? And I thought like, yeah, availability is a problem, so I will do horizontal partitioning, and I'll ask my wife to actually sit with me and then say like, hey, you also do the same, right? So she has a phone, she has a diary, and people call her and they update it. If I go one day sick, my wife can take the calls, even though it will be slower, but still my service is available. Got it? Right? We added a new server into the system. Now I am available,
Yes.
right? I added redundancy. But what is the problem now? The problem becomes here. If somebody calls me to update d of b, right? And we have a system which we like, we at the end of the day we enter all the entries into one diary. So during the day we don't update the storage. So what happens is that some guy updated date of birth, and that call went to me, and I updated his date of birth, right? And then this guy calls again, and then that call went to my wife, and then she has no entry of that person into her database. What went wrong here? Which property is not good?
Consistency.
The consistency went down, right? So as soon as I increase the availability, the consistency went down. Getting my point?
Yes, sir.
Yes, sir.
So they always work against each other. As soon as you try to improve the consistency, the availability goes down. As soon as you try to improve the availability, consistency goes down, right? So now me and my wife thought like, hey, why don't we write on a common store rather than like we have a diary which keeps we both keep together, right? And we write on it, right? So we both of us got the call, and then we want the diary to be written, right? So if she writes one line, I write one line, we will screw up the entire data, right? And that's again a consistency problem. So even though there is a common diary, and if both of us are writing there, we have to take turns, we have to, one person has to write the entire thing, and then other person has to go and then write the other thing. It delays the thing, right? Because the diary is not free to be written. So I try to implement like improve the consistency with availability. Then my latency went for a toss, because now the request which was independently handled at two places has to wait for other one to have sequential one. So the latency goes for a toss here. Getting my point, like how the trade-offs are working here? I started with one basic service, improve the availability, decrease the consistency. Then now, if I try to squeeze in consistency, latency goes up, right? And now what happens? We don't want that latency piece, right? We want the faster systems, right? So we will keep the diaries together, but we will what we'll do is we'll keep on syncing on real time with the database, right? So that's called propagation of the data, right? So but that propagation also requires some seconds, right? So if I called you, I kept the phone and again called you before it goes into the main database, the person cannot answer this, right? So that's the problem with that approach as well, right? So I would like to touch upon the network partitioning, right? Now we have this whole setup of we updating the common request, or we are keeping the diaries with us, and then we update the common database and everything. But one fine day, me and my wife stopped talking, right? And now that is called partitioning. Now my wife is serving the customers separately, and I'm serving the customers separately, and we don't talk, right? So my system is now broken, because even though we are able to serve the request of writes, we will not be able to serve the request of reads again, or properly. That means I don't have availability, right? if i keep if I want to get the network partitioning, right, I should always go to the same person who I wrote the entry into, right? That drops my availability, because if that person goes down, I have no way to go get my data, right? So if I want to improve my network partitioning, that if me and my wife don't talk, still our user get to update their date of birth and read their date of birth, then we have to make sure that both of those operations will happen on a one person diary, right? And in that case, if I go down, that user is, I'm not available to, service is not available to the user now anymore. So if I improved my partitioning tolerance, I decreased my availability. Are you following my rant here? Like how one thing improvement leads to decrease in the other one?
Yes, sir.
Yeah. So you cannot fix it. That's for sure, right? It's a theory paper. Read on this. What is cap theorem? There is a very good PDF on this which explains the entire thing, consistency, availability, and partitioning tolerance. So you should always design your system to aim for two, not for three. You cannot do for three. That is not possible. Either you will go, you don't do C and A for sure. You always go for CP or AP. Yeah.
Yes, sir.
Yeah, cool. So do you understand cap theorem? Do you understand like how the trade-offs happen? So never get afraid that hey, some part of your system is not awesome or it's not perfectly working, because there are in distributed system there are always trade-offs. If you improve one thing, other thing will go down, and then you try to mitigate that, and then the other thing will go down, and then you try to mitigate that. So it's always like a catching game in a system, in a distributed system, right? So nobody expects you to deliver a system which is perfect, right, in a system design round, but they want you to know like what are the trade-offs. If you're adding cache, what goes for a test? Oh, consistency. If you are adding replication, what goes for a toss, right? It again consistency, but it improves availability, right? Because now there is slaves. uh, Now if you want to write to a slave before getting saying like transaction successful the user, right, in terms of banks, right, then your availability and consistency both are good, right? Oh, sorry, availability goes down because if one slave goes down, your entire transaction is gonna fail, right? Because you want to write on a particular secondary server before committing the transactions on the master. So if that slave fails, so more nodes of failure, right? So your availability goes down even though consistency is improved, right? So if you are interested in like how these trade-offs work, read on that cap theorem PDF for sure. Read on how Kafka is designed, and how Cassandra is designed, and how DynamoDB is designed. All of three have. So if you look at Cassandra, right, and DynamoDB, which is Amazon DynamoDB, both of them have sacrificed consistency over availability. So they want it to be like a write available. There should not be any failure on write. So the system should always be available, but the consistency can go for toss. So consistency, there is a concept called eventual consistent. Eventual consistent means even though it is not consistent at that certain point of time, so one data server has some data and other one has different data, they will eventually converge and have one copy of data, right? So it at t0, right, Cassandra's node 1 can have a data d1, and at t0, Cassandra's node 2 can have a different data. But at certain point of a future, let's say t5, both of them either will have d2 or both of them will have d1, right? So eventually at certain point of time they will become consistent, and then there are protocols around it, right? How do you make system consistent, eventually consistent? But by the time they are not consistent, which data should you use, right? Either you should d1 or d2, right? And that also there are algorithms and there are formulas around it. In Cassandra it's very simple, right? If there are n nodes and n by 2 plus 1 node say one thing and other nodes say something, then the n plus 2 plus n by 2 plus 1 nodes value is taken, right? That's very simplistic view of it, but Cassandra has something called a versioning, right? If you want to delete a data, like n1 deleted the data but n2 has not yet deleted the data and somebody requested the data, so you have versioning v1 and v2, and application layer actually compares like, hey, which one is the latest one, and shows it to the client, right? So there is a lot of going on there, but I would definitely ask you to read on DynamoDB paper, cap theorem paper, and Cassandra's eventual consistency thing. because that will give you a lot of fodder to talk in your interview. Yeah. Any questions before I move?
Any specific sites to read on these, or like these
Uh,
API sites are
yeah, just search, right? Cap theorem, just search, and that first result is, I think, PDF of cap theorem, which was the research paper. And
okay, okay.
if you search on DynamoDB, I think it's pretty solid. Like the paper on DynamoDB, which Amazon built, right? Um, it's very fairly accessible thing. It's not like one specific thing. If you want, I can share the PDFs as well somehow.
Sure, sir.
Nice. So, this was the story of cap theorem, right? Yep. Let's go next, right? Next question is, a lot of people feel uncomfortable while answering system design because they know that, okay, this is a free flowing chat. I can speak whatever I want, and then it goes into, like, most of the time you don't even realize that you messed up the interview, right? It looks like, oh, I did a great job there, and then you get the feedback that, hey, it was not as great as you thought, right? So what is the pattern, right? It is being overused nowadays, but still it's a good pattern to to structure your thoughts in a system design interview. Yeah. So how do you structure your system design interview when somebody asks you a random question, design a YouTube, right? So how do you structure your thoughts, right? I want to hear from you, uh, maybe 2 minutes each of one of us, and then if you can tell me, like, if I tell you design a YouTube, how would you go about it? Or let's take a smaller one, design a unique sorry, a URL shortener. How do you go about designing it? So let's start with one by one. I want a volunteer who wants to design it, and then I will tell you, like, how to structure it properly. Who wants to volunteer?
Yes, sir.
Yeah, go ahead.
So we can start with like asking the person ki what are his expectations, what what he wants to the end, what he wants the product to do, and
Mm-hmm.
yes, sir, and what all features apart from the normal one he wishes to add into it, into his system design. We
Mm-hmm.
can ask him that as well,
Mm-hmm.
and what tools we should be using, or what new tools we should use according to him.
Mm-hmm.
Maybe that also we can add.
Mm-hmm.
And
So let's say you got the requirements, right? That's what you wanted to do. Like, you want to get the functional requirements. Hey, what are the requirements of system design? This system, right? And then you got it. Next step. What will be the next step?
next step would be,
Seeing that we want a CP or a AP for the particular job, and then dividing our requirements into different layers,
When you say different layers, what do you mean by different layers?
like the load balancer and all those things, the basics that we
Yeah, yeah,
learned
yeah.
yesterday.
Mm-hmm.
So we'll communicate that these are the different layers that we want. After designing that, we can separate our data according to the number of users that someone specifies. We can design a DB key. Does it require sharding or not?
Mm-hmm. Okay, I think you guys are correct on the path, but let me do a small demo of how to structure system design interview, right? So there are four parts to system design interview, right? And you should structure and time it very well because it's 45 minutes and you have to play the game, right? So the first thing is always collect the requirements. You were correct in saying that, hey, I will correct the functional requirement, what the system should do and should not do also. Functional requirement. And then these are like, sometimes, right, when you are doing, hey, I am doing this URL shortener. Do I need to keep history, or do I need to do accounting, or do I need to do analytics on top of it, right? I would go for like, hey, don't do that, right? Because that will change your system design. Because instead of, if you don't need analytics, then instead of doing 301, or sorry, yeah, 301 is permanently moved, and 302 is temporary removed, or other way around, right? So based on whether you need analytics or not, you will use one of the error code, right? Because if it is permanently moved, the browser will cache it, and they will never come to you for shortener, they will just directly go there, right? So there is very important concept of getting the functional requirement which are in scope, right, which you have to design for, and out of scope, this the functional requirement which you will not support, right? So that's the whole thing. uh, let's say you, and then important is like drive the discussion. So system design has to be driven by you, not by the design, the interviewer, right? So you have to go and pitch in like, hey, if I'm doing URL shortener, let's collect the requirement. I see like, hey, user should be able to send a long URL and get a short URL. What is the requirement of a short URL? Let's go with the 6 characters as a short URL, right? And then there should not be any analytics. Do you want analytics? It will be an API. Do you want to API web design as well? And then those kind of stuff, right? You drive the discussion rather than asking everything from the user or the interviewer, right? So please drive it. Yeah, you can ask their opinion like, hey, what do you think? But don't ask like, hey, what are the functional requirements, right? So that will not go right really well in a system design interview. You have to drive that discussion. You have to come up with the requirements and then clarify like, hey, do you think this is in its scope, or do you think it is out of scope? That is the conversation you want to have with them rather than asking them the functional requirements, right? Cool. Now, very important piece which we skipped in our conversation was, right, non-functional requirement. What do you mean by non-functional requirements? Anybody has any idea?
So it is
Consistency, availability.
Mm-hmm.
basically like deciding how the system should work as a whole, that it should be consistent and available and scalable, and how much pressure users can handle. So that is non-functional requirement.
Yeah, so non-functional requirement is mostly most important latency, right? How fast your system should be, right? Should the URL shortener takes like 15 seconds to get back the shortened URL and 10 seconds to resolve the shortened URL to the long URL, or it should be in milliseconds, right? Latency is very important, right? So always talk about time for each functionality, right? And then you talk about availability, right? So have you heard about SLOs?
No, sir.
Yeah. So let me explain. So SLOs are service level objectives, right? So service level objectives are defined in terms of reliability, availability, consistency, and latency, right? So you should not say like, hey, all the requests of my system will be fast. Yeah, that's a very vague statement, right? Or some people say like, hey, it should be highly available. What do you mean by highly available, right? If your system is like once in a day used, highly available is like at that time it should be available, right? If your system is like used consistently like Uber or Facebook, then It should be highly available in a different sense, right? So what do you mean by highly available, or what do you mean by very fast, right? So that's where we come up with the numbers. So whenever you have this latency or availability or consistency, consistency, all you need to do is like, hey, whether it should be a very strong consistency or weak consistency, right? So your data can has to be always consistent with each other, or in a weak consistency is okay, and that means you can do an eventual consistent system, right? So that's important to know. But in this case, what you need to know is like, hey, 99.9% of my request will go within 100 milliseconds, right? So that's called SLO. That means I do not want 99.98. I want 99.99% of my request should be served in 100 milliseconds. Maybe there are like 0.01%, uh, 0.01%, yeah, 0.01% of the request, which may take more than 1 millisecond. But then I want like, hey, 99.999% of my request should be served within 200 milliseconds. Then you reduce the number of requests which go more than 200 milliseconds, right? So you define your latencies, or you define your numbers in terms of SLO, which is not every system is perfect, right? No system is perfect actually, right? So there will be 0.001% of the request which will always go beyond, right? Something happening on the system, the network is down, the server went down, there is a load balancer switching happening, everything, right? There are like 50 different things which can go wrong, right? So you always keep that one, but it should not go wrong all the time, right? So if you look at 99.99, it's, I think the downtime for your service is 5 minutes in a year. So you can go down for 5 minutes, right? If you do 99, I think, yeah, there is a very good website. Let me share that. Stop share. uh, um, just so that you can read on it. Yeah. Mm, it's uptime calculator, and then yeah, this one, right? So you can put like, hey, if you're 99%, 99.9% SLA is service level objective agreement, which is communicated outside of your company. SLOs are mostly like inside the company, and mostly we work with SLOs. So don't confuse SLA with SLO. It's more or less same thing, but the definition is a bit different, right? That means if you agreed on say 99.99% of the request, or you are agreeing on that, hey, 99.9% of the time I'll be available, that means in a year you can go 8 hours and 45 minutes or 46 minutes already almost in a year. That is the downtime you can have for your service. That means your maintenance, your outages, everything, right? If you increase it to double nine, now you have only 52 minutes, right, in a year to do the maintenance, do the outages. If you're saying like, hey, my service is 99.9%, 99% available, that is what it means, right? And if you say like, hey, there's one, now look at this, only 5 minutes to go down and do the up thing, right? So like if you look at Cassandra, that actually gives us 6 nines, only 31 second downtime, right, in a year, right? So that's the way you communicate your SLOs, right? And then that is what you want for your system as well, right? So you have to define your system in terms of non-functional requirements, latency, availability, consistency, and those numbers can be defined in terms of SLOs like 99. And then you can always define low as well. Huh? No, not everybody has to have 6 nines, right? If your system is something which is less critical, you can have, hey, 99% of the request will go within 1 second. And then above all, yeah, maybe go 10 minutes also, right? So depends on your system requirements, right? So don't fall in love with five nines or four nines, right? It has to be rational for your system. It's just an example which I'm giving. Yeah.
Yes, sir.
Good. So first thing now, you are 5 minutes into the interview. You got the requirements. You got the non-functional requirement. You put the numbers against non-functional requirements, and now you are willing to move forward, right? And this, as I said, it should not take more than 5 to 7 minutes because you have only 45 minutes to design the entire system. So you don't have all the day to spend on this, right? So quickly, just lead it, quickly run through it. 5 minutes, you should be done with it, right? I'm explaining, that's why it's taking more time, but you should be done with 5 minutes. Yeah, cool. Now, the second step is once you got the requirement, functional and non-functional, we call it back of the envelope calculation. What do we do, right? When when our salaries come in, what we do is we do a back of the envelope calculation. Oh, my rent will go this, and then my insurance is this, and my that and this, and then you're like, oh yeah, I will spend like 2500 euros a month, right? That's back of the envelope. It doesn't mean that you will spend 25. You may spend 2600 or you spend 2400, right? That doesn't mean, but it's like back of the envelope calculation that, hey, I need at least 2500 more or less, right? So it gives you a like it gives you a good idea or estimation of what your month will look like and what salary you have to earn and what will you be able to save, right? So that's the back of the envelope calculation thing. It doesn't need to be accurate, first of all. So doesn't need to be accurate. It has to be, guesstimates and estimates, rounded off, right? So nobody is looking, hey, this is not 10 requests, 11 requests. No, that's not going to happen, right? Even if you say 15 requests, it's okay, right? So that's very important. But what do you calculate, right? When you say back of the envelope, but what do I calculate, right? So there are a few things which you should ask your interviewer first, right? Before you start calculating this. The first thing is, ask like what is the scale of their system. And that is very subtle question. And you can ask this information subtly, like you can ask like, hey, how many users are supposed to use this, right? Then you can say like, hey, how many users or how many requests do you anticipate, right? So usually the data given to you is in day, right? Most of the time interviewer gives you the data like, hey, I have, let's say for my URL service I have 500 million user, right? And 10% of them always create a URL, shortened URL, right? So how many URLs will be created in a day? DAC. This is daily active users. 10% of the daily active users create a shortened URL. So how many? 10% of 500 million will be 50 million, and those people create always a URL in a day. So 50 million URLs will be created per day, right? Quickly. Now, how many requests are coming? Because this is only write request, right? This is URL creation, but there are a lot of requests which are coming to read the shortened URL and convert it to the long URL, right? To go to the real page, right? So what is the ratio? And then say like, hey, for each URL, I get 10 requests, right? So every shortened URL, we get 10 requests to read it. So that means every day I get 500 million requests, right? For reading. So I get like per day 500 million per day, and then this 50 million, so 550 million requests per day, right? And this is very important to note, right? With the per day you can't work because 550 million per day, it's very big range. What you have to do is you have to convert this into your per second, like how many requests will come per second, and this is very tricky, right? So how many seconds are there in a day? So 550 multiplied by 10 to the power 6, right? Million is 10 to the power 6. How many seconds are there in a day? 8640, right?
86,400.
Yeah, yeah, 86, this one, right? right?
Yes.
And I don't need to do exact calculation. That's what I say. Like I didn't know to be accurate. Like, I will not divide it, sit and divide it, right? What I'll do is like this is 86K, right? If I make it 100K, so it will be 10 to the power 5, right? 100K is 10 to the power 5, right? And then I will divide it. So what will happen is 500 and 10, right? Because this is 1. And since I increased it around 20%, I will increase this around 20%, right? So this 500 20% is 100. So yeah, 110. So 6,000, right? Request per second, right? Did you notice like what I do? I did not do it accurately, but if you do accurately, it will be around that number, right? We can just check it. Uh, so 550 and then 6 zeros, right? 1 2 3 4 5 6 divided by 86 400.
I'm not able to see the whiteboard.
Yeah, let me, no, you are, I unshared it. Wait, I was just doing a browser calculator. Yeah, look at this. I did the exact division, and this is 6,300 requests per second. And what was ours? 6,600, right? So it's more or less similar, like 300 here and there, which is okay because you are more, right? So actually your system will get 6,300 per request. You are designing it for 6,600, right? So that's the first step you do, like number of requests coming per second based on the data you got from the user, right? From the interviewer. The second thing is, why do we need this request per second? Well, right, first we have how many servers we have to deploy, right, in the web servers and all those things. That is important. The second thing is the traffic which will come, because traffic involves data, and data involves, you need the bandwidth in your network to actually support that kind of data movement on your network, right? So if there are 6,600 requests coming up, and then you say like, hey, every request will contain what, right? Every request will contain, in URL example, it will contain a long URL. What is the size of long URL? Let's say you restrict the size of long URL to be 500 characters, right? And then every response will send you 6 characters, right? So the request will be 500 multiply by these many, right? So this will be 30, 33, and then 40, right?
Sir, 1 second. I understood how many users are 500 million, but what is 10%, and why we have taken 50 million again as 550 total?
Yeah. So do you know the concept of daily active users? So Facebook has 2 billion user, or YouTube has 2 billion users on its platform. That doesn't mean like all 2 billion users come to the platform daily, right? Right?
Okay, okay, yeah.
Then you calculate the percentage of daily active users, right? Hey, these are the active users who, like, a lot of people are there on Twitter who visit Twitter like once in a week, right? But there are people who use it daily, right? So daily active users are the users who come to your platform daily, right? And that is not the total number of users. Total number of users is a different game, right? You may have 2 billion users, but only 10% of them come daily to your right, because that's what the earnings come up, and then all those things. Coming back, why did we do the 10%, right? We did like, hey, we have 500 million users in our system, but only 10% of them create URLs, others just use it, right? So that's why 50 million came up, 10% of 500 million, right? Why I added it? Because I wanted to get the
Creating
number of,
URLs, you mean?
creating URL means when you do URL shortener, right, there are two functionality of URL shortener. One is sending the long URL and getting the shortened URL. Yeah, that is the functionality of the URL shortener,
Okay, so
right?
maybe I'm confused. So what I understood by this URL is like I thought it as a redirection URL. shortening is like, I thought, say for example, we have n number of nodes, each have some node name. So usually if we give that node name also, we'll go to that server. But we'll have an indirect URL, right? Direct URL and indirect URL. Am I is it
Wait,
different from
wait.
what?
Yeah, wait. I think you got the wrong problem statement. Problem statement is this: you have been given a long URL, which is like google.com/this and this and this and this that, right? What your service does is takes this long URL, right, and generates the short URL. Have you ever used tiny.url? Have you ever used this? Have you used Twitter?
Yeah, I have seen. Yeah, yeah.
Yeah, or have you used Bitly?
No.
Right. All these are URL shortener services. So what it takes is it takes a long URL on the internet. You send it and it gives you a code like tiny.url slash some 6 characters or something, right? That's your short URL. Now you can use this to put anywhere so that you don't have to put like all the parameters and all the things which are coming in there, like a big URL, right? You don't have to put it, especially in Twitter, where there is a limit on characters, right? So, and that is how it grew actually, tiny URL. So now the functionality of that system was take the long URL, generate the short URL, and send it back to the user. So if I am the user, I am sending the long URL, you give me the short URL, right? As a service. That's the functionality number one. Understood?
Okay, but what is the purpose of converting a long URL into a short URL?
You tell me.
Is it as like Elia's name?
That's what I'm saying. Have you ever used Twitter? Because then I don't have to explain you the purpose of it. Twitter has a limit of
Lim-
140 character. Now I think they have 280 character, but till recent they had 140 character limit. Remember?
yes, sir.
Now you want to share a URL which is 300 characters long. You cannot share it on Twitter because the tweet size is 140 characters. What will you do? You will shorten it, right? And then put it there. But now you
Yes.
shorten the URL, right? Now, if I click on this, I should go to the original long URL, right?
Okay. Okay.
Right.
Got it.
Your service does two things now. Like first, it converts the short or long URL into the short URLs, and when somebody clicks on the short URL, it converts it to the long URL and redirects the user to the long URL, the original URL.
Okay.
Getting my point? Like, did you understand the
Sure. Sure.
functionality of the
Got it.
service, right?
Yes. Yes. I got it. I got it.
Yeah. So now this was the first functionality, the long URL to the short URL. This is called write functionality. You are creating a URL, a shortened URL. You tweeted it, you created a shortened URL because your request went to the server, it got you the 6 characters, you put it into your Twitter, and then that's what you created. But there are like 50,000 people who are following you now, right? Who saw your tweet and now started clicking on that leak, that shortened URL. That's where your shortened URL click actually comes to your service and say like, hey, what is the long URL for this particular URL, shortened URL? That's called a read request. You understood? The write and the
That's called
read request.
a. Okay. Okay. So here one more, like, I have one more final note. So we have 500 million users who are not active, but we have 50 million requests per day. Like, say for
No.
example, tiny URL is a website wherein we give a long URL and we get the short URL. So
Yep.
out of the many internet users, maybe hardly 50 million people might use it. So
Nope.
why are we preparing something for 550 million?
That's what I'm saying. No, you understood wrong, right? What I'm saying is what I saw told was your service has 500 million, not the internet. Your service as a, let's say, Uber or tinyurl or YouTube or Google or Facebook, as your service you have 500 million users,
Yes, yes,
not internet, not anybody on internet. Your
yes, yes,
people in your service,
yes, yes.
these many people have registered, right? Out of them, like, registration doesn't mean that they all will use it. Do you understand that, right?
True, true, true.
So
Yeah.
Facebook, 2 billion users don't log in every day, right? So
Yes, yes.
what I asked was daily active user concept. Daily active user concept means how many people log into your service on daily basis, right? That I told, like, hey, 10% of your user base, which is 500 million, actually logs into or uses your system to create URLs, right? Getting my point? To create
Yes,
URL.
yes, yes.
So how many people will be creating URLs now?
50 million.
50 million people will be creating URLs. So how many URLs will be created in a day?
50 million.
50 million URLs will be created. Now, what I said was, for every request which is or every shortened URL which is created, there are 10 read requests, because 10 people will click on it, because that will send a read request to your service, right? That, hey, give me the long URL for this short URL, right?
Yes,
This is long to short, right? This is what.
yes.
And then for every URL which you converted, there will be at least 10 requests to convert it back to short to long, because we want to original page,
Yeah, got it.
right? So how many total requests will be there on the read?
500 million.
500 million. So now how many total requests we have?
550. Yeah, got it.
550. Now you got it,
Yes, yes, yeah.
right? And now, did you follow the further conversation, how the number of requests per second came up?
Yeah. I got that. Yeah.
Yeah. Okay, now we are trying to do, like, hey, what will be the request to response size, because the number of requests is okay, but we want to know what data will be flow on our servers, right? So what we'll do is, like, hey, 50 million requests, both of them, like, one will give the short URL and get the long, and then one will get the long and the long and the get the short one. Both of them, let's say, will be 500 character for long, and short is 6, so 506 character. And then we'll be sending user ID and then some dates and parameters or all those things, right? So maybe like 1,000 bytes per request, 1,000 bytes will be there, right? You can calculate it accurately, but it's okay. You can say like 1,000 bytes per request. So that means 550 million multiplied by 1,000 bytes will be flowing on your networks, right? This is the number of requests going into per day, right? And then we had like 6,000 something, right? 6,600 requests multiplied by 1,000 bytes flowing around in your network per second. That means you have what, 10 is power 6.6, 10 is power 6, right? Bytes flowing on your network, right? That means 10 is power 3 is 1 kb, 10 is power 6 is 1 MB, 10 is power 9 is 1 GB, 10 is power 12 is 1 PB or TB, sorry, and 10 is power 15 is 1 PB, right? So how many bytes are this? How many megabytes or gigabytes? What is this? 10 is power 6. It's megabytes,
1
right?
MB.
It's megabyte, right? Yeah. So it's 6.6 megabytes per second, bytes, not bits, huh? So multiply by 8, it will go around like 50 megabits per second. So your network speed has to be 50 megabytes per second, right? That's the data which will be flowing in your system. Yeah. So when you design a system, you need to know what will be the data flowing around in your system. This looks very small, like 50 Mbps is nowadays like nothing, But if you look at Google and if you look at YouTube, where the size of the data is so big and each request is so big because of the video content and the images and the metadata and everything, this can go easily up to like when I was designing YouTube and I did the back of the envelope calculation, it went all the up to like 50 gigs per second, right? So, or even 100 gigs per second, right? So don't underestimate that network speed is given like 50 MB, right? It has to be designed for. Yeah. So that's the first thing you do. Like from number of users and number of requests, we got this, like, hey, how much data will be flowing over the system, right? And the second thing will be how fast your storage has to grow, right? So we have 500 million users, right? And then every day we get 50 million new URLs to be created, right? Each URL stores like user ID, long URL, and then you store short URL. That's the bare minimum you store, right? So let's say you store 500 bytes per user, right? So that will means 50 times about 6 times about sorry times about 500. So this goes around 25,006, right? So this is 2.5 into 10 to the power 9. Oh, sorry, 25 10 to the power 9. What is 10 to the power 9 is a gig, right? So your database will be growing by this size every day. Every day, this is the size of data which will grow, right? So you need servers which can keep up with this kind of growth. Yeah.
Yes, sir.
So now you got like, hey, how much data storage will grow and how much network speed I need and how many servers I need, because I know the 6,600 requests coming per second. So at least one server can, on an average grade server, can easily take, and this is a short request. So maybe easily take like maybe maybe 10,000 requests. So one server will be enough per second, right? But the problem is one server creates a lot of trouble in terms of availability. So anyways, I'll keep 2 or 3 servers, right? So yeah, and then for this is more of a database design system where you have to scale this design, right? 25 gigs per second. Right? So now this is like next 6 to 7 minutes for your interview. So you are 12 minutes, 15 minutes into your interview, and now you have done the requirements and you have done the backup, the annual calculation. Now you know the system very well. Hey, how many users? What is the network speed? What number of requests coming in? What size my database is growing? So you have full information with you. Always when you are doing whiteboard, just keep in the when we were kids, we were doing like rough uh, in the sheet, right? Always write down these numbers so that you can refer them back, so that you don't have to remember them, right? And then requirements also, like, hey, this is what we agreed upon, so that you can refer back your high level design and see like, hey, if I covered all the requirements we agreed upon. Yeah.
So can you tell what that 500 is for?
Which 500? Oh, yeah. So if you store this kind of a database record, right? So you want to store like, hey, which user created it, right? So the user ID of that guy, like let's say 8 bytes, and long URL limit was more of like 500 bytes, like 500 characters, and short URL was 6 characters, right? So overall it's 514 characters, right? That means for 514 bytes, I rounded it off to 500 and then multiplied it with the number of requests will come in, right? So that gives me the number of data, the amount of data I have to store.
Yes, sir.
Got it? Any questions before I move forward? Did you guys know this beforehand?
No, sir.
So this is a short application that we are talking about. But let's say the interviewer asks to design a YouTube or anything else in
Yep.
which we're storing a lot of data.
Yep.
So calculating each byte won't be possible, correct? Like we have a nested JSON that we have to store in a DB. So at that time we have to calculate all these things. Like you
So
said.
the first statement I told was it doesn't need to be accurate, and it doesn't need to be everything,
Yeah.
right? It should be a rough estimation of your system, right? So you don't need to go every JSON column, and then that will be crazy, right? And you will not even know like what all JSON columns you are storing, and how do you know that you are storing JSON columns, right? At this point of time, right? This the point of time only you know that this is the information I'll require, right? In YouTube, right? You store like metadata, right? And the thumbnails bounces everybody else, because thumbnail each one is 10 kb, and no matter what JSON you store, the 10 kb is a huge amount for any text based storage, right? So you'll never surpass 10 kb, so you just round it off to 10 kb, right?
Okay.
So yeah, don't go for very accuracy. You go for estimations, and go for like you know getting things approximately correct, not every field and every column. In this case, that the user id, long url, short url, I just showed that, but there will be like date stored, when it was created, maybe expiry time stored, when it should be expired, maybe it's like active or not active, right? Is it maybe analytics is stored, like there will be a lot of things which will be stored behind it. But for my system to work as an MVP, this is enough,
Okay.
right? So I did not go into that detail. So be cautious. So it's very easy to get into a rabbit hole. You know, a rabbit hole, right? So
Yeah.
the rabbit hole is where you start going into one direction and going deep. Nobody expects it in a system interview. In system design interview, everybody expects the breadth, not the depth, right? So you
Okay.
have to make sure. That's why I'm very consciously telling you like, hey, spend only 5 minutes on this, spend only 7 minutes on it, because most of the time we spend like our big chunk of interview talking about one small problem, and then fixing it, and then fixing it, and then fixing it, right? And then no, we don't show like, hey, we covered these aspects as well, right? So don't go into that trail, rabbit hole trail, right? Just be abstract from that and talk on the upper layer. Yeah,
Okay.
that's a very
Okay.
common trait I have seen. Yeah, good. What next? Once we have done it, what next? The next
Now we
step
have to
is,
design.
sorry, you were saying something.
Now we have to design this whole thing, right?
Nice.
So do we convey all this to the interviewer ki we want this, or we have to keep it to ourselves about the 25 GB and all those things?
Oh no, you have to convey it, because you spend like 12 minutes of interview on this, right? So you want to tell him like what did you do in 12 minutes, right? So please, and this is very important, because even though design interview has to be led by you, it has to be collaborative, right? So like a lot of like this is our I think this is very important thing to know as a software professional, right? I don't know like how much experience you guys have as a software industry, but the thing, nobody likes a person who just takes away the discussion, right? I don't know where
Yeah.
I left India 5 years back, so I don't know what the culture is right now there, right? In terms of work culture, but in US or in European countries, nobody likes a person who just talks, right, in a meeting, and just puts his opinion without consulting other people, right? And I think that's the same in India. Nobody likes a person who just comes like, hey, this is my opinion, my way or highway, right? So even though it has to be led by you, the behavioral aspect of it is like asking for feedback, asking for their opinions, asking for telling them what you're doing is very important, specifically in system design, because in real world you don't design systems alone,
Hmm.
right? So if you don't have that tendency to ask for feedback, and you don't have tendency to communicate what you're thinking, right, it gives a strong red flag straight away. Even though you design the entire system, you may not get the interview, right? So be very cautious about the behavioral aspect of system design, and that's what I'm focusing a bit more on there as well, like time management, asking the opinion, leading the design interview rather than asking everything from the user or the interviewer, but leading it and asking for their opinion about it, right? So yeah, it's a very easy question to ask, like what should I do, right? You can always flip the question and say like, hey, should we do this, right? It's like it's kind of a sky and the earth difference between these two questions. Look, what should I do is like, hey, you are always asking what to be done and you have to be told what has to be done, compared to, oh, you are proactive and you came up with the idea and you communicated it, it got the feedback, asked for others opinion, a entire set of different feelings of an interviewer, right? So please be careful around system design interview. It seems very easy, but it's like these are subtle flags which can take down your interview. Yeah, especially the rabbit hole thing. If they notice that you go into rabbit hole and start perfecting a system, that's the big red flag, because people want a working system and then optimize it rather than optimize system which doesn't work. Yeah.
Yes, sir. Got it.
Good. So that's my rant on behavioral aspect. I like, even if you like when I do system design interview in my companies, even if you are yeah okayish on your system design, but you have this behavioral traits, I would go for a yes. Then you have a perfect design, but you never ask my opinion or you never got the feedback and never share what you're doing. It will be a no. Yeah. That's my personal experience, and this is what I have seen in two companies I have been on interview panels. Yeah. So now let's do the high level design. So in high level design, we don't do much, right? We do the same diagram which we drew yesterday. So we have this load balancer, we have this user which asks this, we have this web servers, we have this application servers which are talking to database, right? That's our pretty much system design, right? High level, right? But what will be the bottleneck here as the request grows, right? The first thing is that this database, right? This is like single point of failure, so you will anyways replicate it, right? And your write request will start coming to this and your read request will go into slaves, right? That's okay. But the slaves are or the secondary servers are still database, so they are storing the data into a persistent system, that is a disk, right? And disk reads are very expensive, so what will we do?
Store the request in cache.
You will store the request into the cache. So if lot of request lot of url shortener are being actually accessed again and again, you'll store them in a cache, so that you whenever this request comes, you look into the cache. If you find it, you return it. If you don't find it, you go to the database, pull it in the cache, and then return it back, right? So that actually explains the read latency, right? So that's the cache. This is the disk or the persistent system. This is okay. So now we got the high level design of the system. I think everything is pretty simple right here. You don't need to do much stuff here. Now the problem starts when you write the thing, right? So that is where you are doing the generation of the hash code or generation of the key, right? So like a long URL to a short URL. That's what you're doing, right? Right. That happens on the application server and then it goes into the database, right? Right. You have bunch of characters. You have to reduce it. That's the problem statement, right? You're doing that. How would you do that, right? Because that requires processing, right? Any idea on that?
um, Save it in DB, like prepare a short URL with some pattern, like usually YouTube URLs will have some 16 to 18, 16 characters, some unique pattern. So for each, and maybe that will redirect to a long URL. So storing the long URL and generate a short URL for the long URL, store them in DB. I'm not sure if DB is a correct place to store, but so while creation, create a short URL, store the long and short in the DB, and while any user request for that with the short URL, go back to DB, fetch the long URL, and redirect the user to that particular URL.
Yep, I think that part we covered, right, with the cache and the write and the database. Let's say, right, the database is okay for now. My question was like when you said like convert the long to short URL, I'm focusing and zooming on that piece. Like, how would you do that?
So we can start, like if we want a 6 character long URL, so we'll start with 6 random characters. After generating the character, we'll see that if that particular string exists in the database. If
Mm-hmm.
that's not the case, then we'll store the new string in the database and send the response to the user.
That's okay. So how can you generate that short URL? Like, how can you generate that random sequence or random string which you just said?
So running a loop, 6 character loop, and generating random characters. Like we have A to Z, and then we can generate a hash, like, correct,
Yeah.
taking 6 random characters with the random function and then checking that.
So let's say you do a hash, right? You do a random hash and you get the characters, or it's like alphanumeric hash, and then you send it back, right? Um will it impact your read speed? Sorry, will it impact your write speed? Because now when the write request comes, you take the URL, you generate the hash, and hash functions are pretty heavy, huh? They are not like very fast functions, because the whole idea is that you generate the hash and it should not be crackable, right? So encryption is as tough as decryption. Decryption is much more, but encryption also takes a lot of time, right? Doing the hashes and doing the whatever you said, it takes processing time, right? It's not fast, right? Every request will take not 100 millisecond, but it will start taking 1 second, right? Because you have to do all this stuff, right? And then you have to save into the database. Even you have to check before it is already generated or not, and then come back and then you update it, right? So it's a round trip to database. So it will take at least a second before you get the URL on a scale, right? Not at the like one URL per minute. But if you are working at a scale of like 6,600 requests per second, right, this will start taking, because those many threads will not be running, right? So you have to wait before your request comes in, and then you send back, and then there will be a back pressure build, right? So how can we expedite this thing? Getting my point? Like I can actually dish any approach you sell, so don't feel bad about it that you said something because that's how the interview goes, right? You say something to the interviewer just dishes it out, and then you have to come up with a new idea. So that's what I'm trying to mimic here. I just told you, I think your approach is right. You what you said makes sense, but it will start creating trouble when I scale, right? Because now each URL shortener request will start taking more than 200 milliseconds. How can I expedite this?
Hmm.
What is the step which is taking more time? Focus on that. generating of the short URL, right? You had the hash code and everything, right? But there is no prerequisite of like, hey, this URL should be matched to this short URL, right? There is no requirement like that, right? It's random thing, right? Any long URL can come into any can get any short
You
URL.
can use a sequence number.
Yeah, you can get the
Yes.
sequence, but that's a security risk, right? Because
Okay.
now anybody can guess what will be your next URL, right? Not a good idea. Because now I can just block all those URLs on my servers because I know what will you be generating next. Yeah. So never give away your pattern. So the biggest trouble was doing it when the request comes, doing it the conversion at that time, right? What if I have already a bunch of shorten URLs generated, right? What I do is as soon as a request come, I just take the first one, right, and send it back and store it in the database. That's it. I'm pretty sure it was not in the database. I do not do the hashing and the encryption and all those things when the request came up. I just took it from the store or a cache somewhere and then send it out and put it in the database that hey, this long URL is now associated to this. It's like you have already the name of your kid. I don't know if you are in that stage of life, but for me, right, we had a list of names, right, when we were expecting our kid, and then we just put it one name to the daughter, and then we had prepared it for boy as well. So daughter came, so we picked one and put it like she didn't know like we had 10 other names as well, right? Now she is called by the name we given him. It's the same thing, right? When the URL came, it did not know that we have already generated like 15 different URL shorteners or shorten URL. We'll just take it, put it against that. Hey, now this is your shorten URL, right? And put it in database. Now, when somebody reads it, we go to the database and then gets the shorten URL and they redirect it. So the whole process of generating when the request comes in is gone. Getting my point?
So, so you are suggesting that we have a list like of 15 or 50 million
550, yeah, 50 million, yeah.
50 million, and whenever us like 20 million goes away, we have another thread running to generate other 20 million requests
Yes.
on a different thread.
Yes. On a different process even, yeah.
Yeah, yeah, okay, okay.
So it expedites your response time, right? Instead of like when your kid is born and then going for 3 months to find a name, you already have selected the name,
Hmm.
right?
Got it.
It's a very weird example, but if you have a kids coming very fast, then you will run out of names, right? For because you are taking three months to take the one name, right? So if you have a list, 10 kids, you just have names ready. You just also allocated the name, right? So you expedite your system like that.
So, sir, in this example,
Mhm.
like if a user requests for a short URL and another user who's requesting for the same long URL, then he will be assigned the same short URL as the previous person, or a new one would be picked from the list.
Very, very good question, right? This is very, very because this is called concurrency problem, right? And this approach actually suffers from that, right? And that is where you have to be careful when you are storing into the database, right? So even though you have generated the short URL beforehand, before storing into the database, you have to recheck it that if this particular URL is already created or not. If it is created, it will take the original created URL shorten and return back. Good question. Concurrency problem. It was already a problem like if there are like so many requests coming at the same time, like 6,600 requests, right? Which one will get the first one and the second one and the third one because now both the request can go here and both of them can get the same request, the shorten URL, right?
They
Right.
have locking mechanism for that.
Yep. The locking is there. Distributed locking is a nightmare, by the way. right? Even with the threads locking, it creates a lot of trouble. I can imagine with what will happen in the distributed system, right? And then if somebody goes down with the locks with it, your system is in a deadlock now. So good idea, but doesn't work on distributed system. So rule of thumb, never try to do locking on distributed systems. It never works, right? So what else? Maybe split this, right? So like if you have 1,000 threads, maybe split it to 1,000 threads, and no same thread can go to the same block, right? Shard it, the keys which you have done, so that every time one thread can read from one, right? So you actually mimic the sequential there. Getting my point?
Yes, sir.
Okay. So shard it so that each thread goes there, right? That is one way to do it. But locking, no, please do not do distributed locking. It's very difficult to get right. What
So,
else is the problem? Yeah.
you are suggesting to split the list.
Yes, split the list.
So, but the problem can be that the two different lists can have the same string available over there, right?
Why?
So let's say list one has XYZ and list two also has XYZ. That
Why?
can be
Why? Why that will be happening?
because currently database is not having XYZ present in it. So the list one will think ki it's not there, so it will store it in it. And list two will also do the same. If
Wait,
the user,
wait. What do you store here?
so we are storing the hash over here, right?
Hash.
So yeah,
Yeah. Now you have 50 million hash already generated here,
yeah,
right? And then you split it into like 50 million parts, each one 50 parts, so each one of got million parts,
huh. Huh.
right? So where would you see like the
Acha,
collision?
I was thinking that we have 10 parts of 5 million each, and they are generating strings on their own, the hash on their own. So we are splitting it
No,
differently.
no, 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 no,
I got
no.
it, I got it. Yeah, I got it.
Got it? Yeah. So
Yeah,
the generator is the same, otherwise the yeah, then there is a trouble, right? Generator is the same, then you split it.
yeah, I got it. I got it.
Yeah.
So, sir, in case if in a day we receive more than 50 million requests,
Yeah, that I think already covered, right? Where as soon as you spend like 20 million, you just create new 20 million. So it's a refilling thing. It's sambar on the idli, right? As soon as you run out of sambar, you put more, you
so
know.
this will also cover the problem like if someone tweets with a link, then that short link URL would be valid for lifetime, or it would have a expiry also.
That's a very good question to be clarified in terms of functional requirement. If there was an expiry, what will you do? Let's think of that use case, right? So there are data structures which are very good for expiry, but if you're using storing it in database, right, then you need to run another job on the back end to actually clear them up as the time progresses, right? But if you are using Redis cache or something, it has already a expiry flag on it, right? You can put a flag like time TTL, time to live, that automatically deletes it from the cache. So cache will be taken out, but you have to clean it from the database, the different job, and then you have to put them into a reusable pool, so that when the hash function is being generated, these are now reusable keys, so they can put it again as a recyclable key. Yeah.
Yes, sir.
Think, always think like what can go wrong and how can you build it, right? There is no right or wrong answer here. Even what I'm saying, if somebody more experienced than me comes up, yeah, he will dish it out and say like, hey, how would you do that? That's the third step, right? You got it, like you got the other thing. The fourth step is mostly talking about the optimizations, right? And the technology choices, like I put cache there. Will it be a memcached or will it be Redis? Will it be whatever, right? For the database, will I use MySQL database, or will I use a Cassandra, or will I use what, right? That kind of technology is hash function. Which hash function? Which what will be the list stored in K? Like there are key generator, key sequence generator KSGs, right? Read on that as well, how they work, right? What else is there? Well, yeah, this is a simple problem, but you got the gist. Like you start optimizing, and then you start talking about technologies, right? Kafka, if you're using queuing mechanism, whether it will be Kafka or RabbitMQ, if you're using cache, Redis or memcached, if you're using data store, whether it will be document based, relational, or key value pair. If it is relational, will it be MySQL, will it be Postgres? If you're using document based, why document based? Will it be MongoDB or any other? If you're using key based, key value based, will it be a couch based or a Cassandra or whatever? Yeah, talk. Yeah. So that's how you go into system design round. Do you feel like now you have more structure to the answer or the solution, rather than just going into like five different directions and then unfortunately going into a rabbit hole?
Yes,
Is this more helpful?
yes, sir, definitely. So, sir, for example, if like I have an interview round tomorrow
Yeah.
and it is supposed to be a system design round, but I have no experience, like I'm still a fresher.
Yeah.
So I don't have to talk about the technologies and I can just give the structure and optimize it without talking about the technologies.
Yeah. That will be shallow. I think it will help you to learn couple of technologies. There are not many, right? Know like why Cassandra is useful. Know like why Kafka is useful. Know like you don't have to go into details of each configuration of them. It's just like why Cassandra is useful, what it brings in, right? Over MySQL, which is relational database, right? What is the difference between Redis and memcached, right? So this is good to know, like just a couple of articles you can read, right? And then you should be okay. But do not go blank that I don't know what is Redis, right?
Okay, sir.
Okay, my next batch has arrived. Cool, guys. Okay. So next week, Saturday, we will cover one interview problem. I think we'll cover designing YouTube, right? So let's do that. Let's learn whatever we learn. Let's apply there. So if you find some time, read on YouTube. What are the functionalities? Read on some stuff which are cool there. How video technologies work and all those things, and that will help you in next class. Uh, but yeah, let's discuss that next class. Yeah.
Yes, sir.
Cool. I will see you next
Yes,
week,
sir.
weekend. Yep. Cool. Bye bye.
Thank you, sir.
Bye.